All right, next we are going to talk a little bit about the unit circle. The unit circle is used a lot in trigonometry, and quite honestly this year you guys won't be using it too much, but I want to talk about it. The unit circle is a circle that's been centered at the origin. So at 0, 0, right here, what we have here. What's important about the unit meaning 1, circle, is that it always has a radius of 1. So anywhere around your circle, you always have 1. The radius is 1. It's only ever 1 unit away from that center point. So what we're really going to be doing is creating right triangles inside of our unit circle. We often are using with our special triangles. So at the bottom here we see that we have a 30, 60, 90. And remember, what we're doing is always creating right triangles with the x-axis. So our hypotenuse is always what's 1. So r is 1 here. Now can we build the rest of our 30, 60, 90? Well, we know if the radius is 1 or the hypotenuse is 1, the short leg is half of that. So y would be 1/2. And the long leg would be the short leg times radical 3. So 1/2 times the square root of 3, which can most often will be written as square root of 3 over 2. If we want to do our 45, 45, 90, we have a hypotenuse of 1. So to go from a hypotenuse in a 45, 45, 90 to our leg, we divide by the square root of 2, which we could rationalize that, but we'll just keep it a little bit easier and leave it as 1 over the square root of 2. On this next slide at the bottom of the page, what we need to do is build our sine, cosine, and tangent for 30 degrees, 45 degrees, and 60 degrees. These are the most often used degrees when we're using our trig and finding exact values for trigonometric functions. These 9 different trigonometric functions are ones that you guys really should be able to recall at the drop of a hat. Some teachers require students to memorize them, but what we're going to do here is just build them. So up at the top here with the 30 degrees, we've got our triangle. So if theta is 30 degrees in here, what is r, x, and y? Well, r, the radius, it's always going to be 1. Therefore, if our hypotenuse in a 30, 60, 90 is 1, our short leg would be half of that. And our long leg is 1/2 times radical 3, which we just did and we know is radical 3 over 2. Next, we have our 45. So if our radius is always going to be 1, so our 2 legs in this will be 1 over the square root of 2. Remember, to go from hypotenuse to a leg in a 45, 45, 90, we divide by radical 2. To go from a leg to a hypotenuse, we multiply by radical 2. And finally, in our 60 degrees, so if our radius is 1, our short leg is now our x. So that's half of the radius. And our long leg is multiplied by radical 3. So radical 3 over 2. Now that we have those, we can easily build sine, cosine, and tangent for each one. So the sine of 30 is opposite over hypotenuse. So our opposite is 1/2 over our hypotenuse, which is 1. Which means that the sine of 30 degrees is just 1/2. Cosine of 30 would be our adjacent, so the square root of 3 over 2 over our hypotenuse, which is 1. So we simplify. Cosine of 30 degrees is just radical 3 over 2. And finally, tangent of 30 is opposite, so 1/2 over adjacent, which is square root of 3 over 2. Now to simplify this, we have a fraction divided by a fraction. So instead of dividing by a fraction, we're going to multiply the top by the reciprocal of the denominator. So now it's 2 over square root of 3. So I can cancel. I have a 2 up top and a 2 below. So what I end up with is that the tangent of 30 would equal 1 over the square root of 3. Go ahead and use this information to be able to do your sine of 45, cosine, tangent of the rest of these, and I'll give you the answers here in a minute.